So in previous video we talked about the structure of IP version 4. In this video we are going to talk about different IP version 4 classes. There are 5 different classes. Let's first talk about class A. The range for class A goes from 1 to 0, 1. So here we are talking about the ranges of these classes, class A, B, C, D, and E. For class A, in the first octet, it's pretty much all 0 except the last one, and it goes to the first 0 and all 1. For class B, the first octet goes from 1, 0, 0, 0, 0, 0. C is the first 2 on. D, first 3 on. And E, first 4 turned on. So in class A, the first octet, which we talked about, this is the first octet. The first octet range goes from this binary to this binary, which when we convert the binary to decimal, gives us 1 to 127 in the first octet. And 127, I should talk about that, which is pretty much reserved for the loopback address. So for example, when you see IP address of 127.0.0.1, that's an example of loopback address. So this is the first octet, 127. It's reserved for the loopback address. Therefore, when we talk about classes, most likely you will see for class A, range goes from 1 to 126 in the first octet, because 127, it's reserved for the loopback address. And what is this loopback address? Mainly used for troubleshooting, testing purposes. So anytime when we ping the loopback address, for example, when we open command prompt by pressing start, typing cmd, enter, opens up command prompt, and when we type ping command for testing connection, so ping loopback address, ping 127.0.0.1, enter, it's basically pinging our computer, the TCP IP services, to see if it's up and running. So ping command by default sends for echo request and for echo reply, uses the ICMP, Internet Control Messaging Protocol, for testing connections. And here we can see for echo request and for reply, 0% lost. So anytime when we are pinging 127.0.0.1, it didn't go through, it's most likely our computer. The problem is with our computer. It could be firewall, could be the network adapter, device driver, the TCP service is not running. So we have to start troubleshooting our computer. So this 127 address, it's known as loopback address for testing connection and troubleshooting. Okay, let's move on to class B. When we convert this binary to decimal, that's 1. So the decimal value is 128. If we quickly go over these decimal values for these binaries, so this one is 1, 2, 4, 8, 16, 32, 64, and 128. So this one, it's 128 turned on. So it is 128. And for class C, 128 turned on and 64 turned on. So 128 plus 64 is 192. And for class D, so 128 plus 64 plus 32, that's 224. And for class E, here we can see the first 4 bits turned on in the first octet. So 128 plus 64 plus 32 plus 16, which is 240. And here we can see for class A goes 1, 2, we talked about 127, it's reserved for the loopback, so we are using 126. And then the next one is 128, right? So 128 to what number? One less than the next one. So 128 to 191. And then for class C, the range is 192 to what number? One less than next class range. So 192 to 223. 223. And then for class D, 224 to what number? 239. One less than the next one. So 239. And for class E, 240 to what is the maximum number? 255. So just keep in mind, in IP version 4, we have 5 different classes. Class A, B, C, D, and E. Class D mainly used for multicast addressing, and the range starts with 224 to 239. And then class E starts with 240 to 255 in the first octet. And class E mainly used for research and scientific purposes. Class D used by routers, routing protocols, it's a multicast address. Class A, B, and C we will use to assign to the host interfaces, and mainly we will see subnet mask for class A, B, and C. And in the next video we will talk about the subnet mask more in detail. But before that, I'm gonna go ahead and write down multiple different IP addresses and ask you guys what class it is. So first, let's say 32.18.9.21. This one, 125.64.18.5. This one, 235.15.9.16. This one, let's say 85.315.19.21. Okay, let's take a look at the first IP address. This one, 32, this is the first octet. So looking at the first octet, 32 falls into what range? So 32 falls between 1 to 126. Therefore, this IP address is for class A IP address. Let's go ahead and move on to the next IP address. By the way, these are known as dotted decimal notation. Basically, these numbers are already converted from binary to decimal. So originally here we can see it's a binary number, but it's already converted to decimal. Easier for humans to be able to read. But that's the actual 32 bits of IP address, and this is known as dotted decimal notation. Okay, looking at the first IP address, 125. In the first octet, 125 falls into which range? 125 still falls into the first range, between 1 to 126. So that's also class A IP address. Now let's go ahead. Next one, next IP address. The first octet, 235. So 235 falls into class D range, because class D range goes from 224 to 239. Therefore, this IP address, 235, falls into class D. And next IP address. Well, if you guys said this is not a valid IP address, you are right. Because we don't have here on the second octet 315. Remember, every octet, the range goes from 0 to 255. When we convert, if all the bits turned off, that's 0. If all the bits turned on, that's 255. So here, on the second octet, which this is the second octet, it says 315. 315, it's not a valid number in an IP address of the octet. So this was kind of tricky question. Be careful, this is not a valid IP address. If this was, let's say, correct number between 0 to 255, then looking at the first octet, 85 falls into still class A, so it would be class A IP address. But 315, that's not a valid number in an octet, so this is not correct IP address. In other words, we don't see IP address of, let's say, 192.65.18.9, or another word, 192:65:18:9. So we don't have dashes between the octet, we don't have colon between octet in IP version 4, we have dots, as we can see here. And of course, the numbers in every octet, it's pretty much from 0 to 255. Why? Because in 8 bits, the maximum number we can get is 255 if all the bits turned on. For example, if I quickly show you guys, on a third octet, let's turn on all the bits, and if we add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that's 255. And if all of them turned off, in a binary, again, in the previous videos we talked about, I highly encourage you, please make sure you watch here. So how we can convert binary to decimal. So if all the bits turned off, it pretty much, we don't need to add any of this value. Therefore, the decimal is 0. If all the bits turned on, we need to add the ones that already turned on. In this case, all the bits. So we have to add 128, 64, 32, all of them. When we add all together, that's 255. So that is why in every octet, we see the range from 0 to 255. And here, 315, that's not correct. So this is not a valid IP address. And these are not valid IP address. I'm going to write down another IP address and ask you guys what class it is. 165.19.32.64. If you said class B, that's correct. Because looking at the first octet, 165 falls into this range between 128 to 191. And that is for class B. So quick summary, in IP version 4, there are 5 different classes. We can see the first 3 classes used for the host and interfaces, and class D used by routing protocols and routers, that's a multicast address, and class E, it's for scientific and research purposes. And the ranges, always class A in the first octet, we can see the range goes from 1 to 126. Class B, in the first octet range, we can see 128 to 191. Class C, range 192 to 223. Class D, 224 to 239. And Class E, 240 to 255. Where this range is coming from, looking at the first octet, here, these are the bit values. And why is that? Because in class A, when a router receives a packet, looking at the IP addressing, IP address header, always, if it starts with 0, it knows that that's class A. Because if we look at class A range, it goes from 0 to 01. You see, all the range, always the first one, it's 0. So that's how routers quickly know, oh, that's class A. And for class B, 191, if we convert 191 decimal to binary, it will be 2, 1, 0, 1, 1, 1, 1, 1, 1. So let's count. It should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Very good. So always class B range goes from 1, 0, 0, 0, 0 to 1, 0, 1, 1, 1, 1. And of course, total of 8 numbers here. So always the first 2 bits in the first octet, it's 10, and that's how routers know that this is class B. And looking for class C, always the first 3, very good, you guessed it right, 110, 110. So always the first 3, it's 110. How do we know? Because when we convert 223 decimal to binary, this is the binary for 223. And the next one, the range, you guessed it right, for class D, always it is 1110, and then the rest 0. 2, 1110, and the rest it's on. 1, 2, 3, 4. That's total of 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, when router receives a packet, looking at the IP header, the first 4 bits, if the first 4 bits it's 1110, it knows that this is class D, because in class D, the range always, the first 4 bits, 1110. And same applies for class E. Always the first 4 all turned on. When a router receives a packet looking at the IP header, always class E, the first 4 bits, 1111. So basically, in other words, 2. So we have the first 4, 1, 2, 3, 4, and the last 4 also turned on, and that's a total of 255. If all the 8 bits turned on, that's 255. But again, in class E, always the first 4 bits is turned on. So this was a quick overview of IPv4 classes. Again, we have 5 different classes. You should already know by looking at the IP address, how can we tell this IP address belongs to what class? You should already be familiar with the ranges. Class A ranges, for example, class B, class C, class D, class E. You should know and be familiar what is the purpose of class D address. Class D addresses mainly used for multicast purposes. Multicast communications are one-to-many defined groups. For example, one transmits to multiple different devices at the same time. So this known as multicast communications, like let's say video conferencing and so on. And class E, it's used for scientific and research purposes. And always in the first octet, the range starts with 240. So if you see IP address, for example, let's say 242.18.9.24, you should say that this IP address, 242, that's class E address. That is mainly used for scientific and research purposes. So here we had some example of IP addresses. And looking at the first octet, we can tell if this is class A, B, C, D, or E. But just simply double checking and making sure if it falls into that range. In the next video, we are going to talk about these classes and their default subnet mask. Thank you so much for watching and have a good day.